Major and minor losses in piping systems. So we can categorize the energy losses into two types, major and minor losses. Introduction to losses in piping. So the piping, generally the losses which occurs because of our major and minor losses. So the major losses is caused by the friction losses, and the minor losses which occurs due to sudden expansion, sudden contractions in a pipe system, obstructions in a pipe systems, bends in a pipe, and the fitting in a pipe. So we can calculate the losses by using an various equations and formulas. Major losses. So the major losses which occurs mainly due to the frictions along the length of the pipe. So these losses are influenced by the factors such as pipe length, diameter, and the fluid velocity. So it's very important to understand the major losses, so which helps in calculating the head losses and ensuring the proper system designs. So we can calculate the major losses by using a Darcy's-Weisbach equations or by using a Chassis formula. Minor losses. So minor losses refers to the energy losses. So sometimes in some pipe systems minor losses are negligible. So we take in very small pipes, so minor losses are negligible. We can consider only the major losses which occurs due to frictions. So the minor losses which refers to an energy losses which is caused by fitting, bending, valves, and other components in the piping systems. So although they are termed as in minor, they can significantly impact. So this minor losses which significantly impact overall efficiencies. So the proper assessment of these losses is very essential for an accurate system analysis. So calculating the major losses. So to calculate the major losses, Darcy's-Weisbach equation is commonly used. So these equations considers the friction factors, pipe length, diameter, and the fluid velocities. So understanding how to apply these equations is key to an effective piping system design. Calculating minor losses. So the minor losses which generally occurs due to sudden expansions of one piping system, sudden contraction of one piping system, pipe fitting, pipe bending, and which may be due to an obstructions. So the minor losses can be calculated using a specific K value representing its loss coefficient. So the K factor method, where each fitting has a specific K value which represents its loss coefficient. So summing these losses means adding the total losses, which helps in determining the total energy losses in the system. Impact on system designs. So understanding both the major and minor losses is essential for effective piping system designs. So these losses affects the pipe selections, energy consumptions, and overall system efficiencies. So we as an engineer must account for these factors to optimize the performance and reduces the operational cost. Real world application. So in real world scenarios, industries such as oil and gas, water distribution, HVAC systems must consider the losses in their designs. So the case studies which demonstrate how addressing these losses can lead to significant savings and enhanced system reliability. So overall, it's very important to understand the major and minor losses in piping systems. So it's very important for optimizing the performance. So by accurately calculating these losses, engineers can design more efficient systems. So which obviously helps in reducing the costs, and also it enhances the reliability of the piping system. So we must have to consider these factors when we go for designing the pipe systems. So we have to look after both the losses, major and minor losses. In some cases we can ignore the minor losses, but it's very important and essential to include the major losses, as because the major losses is caused by the friction losses. So when the losses due to a pipe bend or it is due to a pipe fitting, these losses can sometimes be negligible, but when we go for a large diameter pipe, we have to look after even the minor losses, because it impact the overall efficiency of an system. Which impact